That's all right. I didn't say anything that can't be missed. So today we're just covering definition of a function and function notation, which again, Tom covered in the videos. So I will do the practice problems more so. Tom's videos are very clear on this. They're very good. So when we talk about functions, we have really two pieces that are important. We have something called the dependent variable, which is usually y, usually, not always. And we have the independent variable, which is usually x. So what I mean by this is one variable depends on the other. So for example, let's just say we have the function y is x plus 1. Which of these variables depends on the other? Well, y depends on x because we need to put x in. It needs to be added, 1 needs to be added to it in order to give us our y. So this stuff happens and then it gives us the y. Y depends on whatever you put in. In other words, the dependent is the output and the independent is the input. So for example, you go to the movies. The number of people that go to the movie is the independent variable. It's just 5 people go to the movie. It doesn't depend on anything. You just, okay, you have 5 people. The cost that you're going to have to pay to go to the movie is of course the dependent, because it depends on how many people came to the movie. So I'll use that example again. Y equals 30x. Of course, the cost of the movie, the cost of going to this movie with a group of friends, depends on the people that go. So this is the input, or the independent, and the cost is the dependent because it depends on who goes to that movie. All right, so that's the basic idea. Functions are just ways of taking inputs and giving outputs, and there's 3 main ways that we can represent them. Equations, that's the first way. This is what I've been showing you this whole time. Table of values, which is, well, of course, a table of values. I'm sure you've seen them before. It looks like this. This is a table of values. You put x's in, what is the y? You put another x in, what is the y? And then, of course, graphing them. So every equation or table of values has a graph. Maybe we wanted this graph. This might look something like this, okay? So if you've ever done a physics course or probably any other math course, I'm pretty sure you've seen functions before. So let's go ahead and get to the root of these examples because they've been covered like this in Tom's videos already. Hi, everyone, by the way. I haven't said hi because I've been in the middle of this, but I don't want to waste any time. Hi, Mohammed. So Tom did examples A and B in the video. You can go back and watch that later if you haven't seen it. Let me just show you what we do with these types of examples. So the question is, we want to rearrange each question to find the function and state the independent and dependent variables. So what this means, we need to find the function, state the independent and dependent. Well, really what we need to do is we need to isolate the variable, which means get x or y to one side. So I'll put this to the side. We need to get x or y alone. That's what it means. It means to isolate. So in question C here, which variable, x or y, would be easier to isolate? Which one would be easier to get on its own on the side? Would it be x or y? Anyone have any idea? X. So why do you choose x? I agree with you, but why would you choose x? Why is it easier? Yeah, I think what you mean is it's just in one place. There's just one, right? So for example, we have x here. We don't see any other x's, but we have a y and a y. It's in 2 places. So we'd have to do more work. Yeah, exactly. We're saying the same thing. That's good. So there's actually 2 ways to do this. Let's try isolating x. So the function is 7y plus 3x equals 8y minus 15. I'm going to move everything to the right. That gives me 8y minus 15. And then, of course, I need to subtract that 7y. That moved to the other side. That means we have 3x equals y minus 15, or that is divide everything by 3. So I'll show you this. Divide by 3, divide by 3. That gives us y over 3 minus 5. Now I'm not going to write y over 3. I'm actually going to write 1 over 3y, because for this course it tends to come up. That is actually a little easier once we get into it. So I did that quick, but I wanted to show you it so that we could get through more things. Good morning, Mom. Right now, it asked, find the function. Well, I have the function now. This is the function. But I also need to state the independent and dependent variables. Now, be very careful. It is not always x and y, and there's not some way of memorizing that. You need to look. Which function is alone? Whichever one is alone will be the dependent. Because it depends, it is the output. It depends on what the input is. So in this case here for C, which one is the independent and which one is the dependent? What is X here and what is Y? Anybody have any ideas? X is the dependent because it depends on the Y. Y is the independent because we can put whatever we want in there. It does not depend on anything. We can put 100 in there, right? 1 over 3, if I put 1 over 3, multiply by 100, minus 5, it gives me a number back. I wasn't restricted to what I was allowed to use for Y. I can put whatever I want. Of course, X is whatever gets thrown back. It's the dependent. It depends on what I put in for Y. So let me go ahead and say, all right, what if I had chosen Y? Maybe you wanted to choose Y instead. Well, let's do that. Let's see. I want to try solving for Y. I want Y as my dependent. I want to isolate it. So I'll say 7y. I'm just going to go ahead and rearrange to begin with. Bring the 8y over. Negative 15 stays where it is. It will gain the negative 3x. And then what do I have? Negative y equals negative 15 minus 3x. And then, of course, I've got this pesky negative here. I need to multiply everything by negative 1. So I can cancel it, cancel it, cancel it. It becomes positive, all right? 15 plus 3x. And that's now isolated. It's on its own. So I ran out of space a little bit here, but I'm just going to rearrange. Tell me in the chat, say X, and then type dependent, DEP, or independent, okay? I want you to tell me which one's which. Just got to do a little bit of moving around. So Abdul, you're saying X is independent, Y is dependent. So X in this case is independent. I agree with you because it doesn't matter. We can put whatever we want in for X. Y is dependent because it's the output. It depends on what gets put into it. So I'll just quickly say independent is the input. Dependent is the output, right? Dependent is the output and the input. Okay, so this is how these things work. Now in this case, because it's called a linear function, I'm talking about example C, we're given a linear function, there are no squares. It kind of doesn't matter which one, X or Y, we choose. In D here, I'm actually going to make this something that you try. Which one should we isolate? Which one should we make the dependent variable? X or Y? Remember, we want to go with the easiest way. We want to do the least work possible because we're all lazy. It's all Ramadan time for everybody. We want to do the least amount of work. 2x squared. See, 2x squared I think would be hard to isolate because it has that square. I would be more willing to try solving for the y. No? Because squared, as soon as we do a square, we're going to have to solve for it later. We might get a quadratic. We might get a square root. We should probably stick to the simpler one. Because it's linear, it doesn't have a square. All right? You don't have a square on top. This too would cause us a problem. So because it's a faster class today, because we have that assignment at 10 o'clock, I'm going to go ahead and solve this. You can solve it with me and see what you get, okay? So let's see here. I'm going to solve for the y, which means I want all my y's on one side. I'm going to go ahead and bring all the y's over to this side. And I'm going to bring this x term to the right. So that means I have negative y where it was, and then I'm bringing over the 2y. Remember, when it crosses that equal sign, it changes sign. I don't think I should need to tell you this, but you never know. Equals 9x stays where it is, and then I'm going to subtract 2x squared. Okay, now all I need to do is simplify the y's and divide. So negative 1 minus 2 minus 3, that's negative 6y's. On the right side, it's okay on the right side, but normally we want the bigger coefficient, the squared term in front. So I'm just going to rearrange. What I mean is you like to have bigger x terms instead of the smaller ones in front. We want the squareds in front and then smaller, smaller, smaller. Now we divide everything by 6. So that can disappear. Divide by negative 6, divide by negative 6. We should get, let's see, negative 2 over 6 is 1 over 3. 9 divided by 6. I'll use a calculator just to show you that it comes out with 3 over 2, which of course, if you divide both of those by 3, you get 3 over 2. And I'm seeing that you're saying 3x plus 2. I'm not sure how you got that. This is what I got. So when I got this, that means that y is the dependent, x is the independent. That's kind of our final answer here. Sounds like people are coming and going and coming and going. All I hear is vroom, vroom, vroom. Any questions? I think Abdo's probably the only person that's been paying attention. Maybe some of you are frantically trying to study for the assignment. The assignments, it's going to come no matter no matter if you like it or not. So should have studied for that on the weekend maybe. Any questions I can answer on this particular topic?
A question.
Mm-hmm.
Will you make a quick review for the assignment or?
No.
No.
No. I'll do a review for tests, but not for assignments.
Okay.
If this was a regular semester, if this was like a normal semester, not Ramadan, not intercession, yeah, I probably would. But we don't have time for that. Especially because there's videos online. They are the review. You can watch them as many times as you want. Abdo, what was your question?
Yeah, Mr. Scott, why you separate the minus 2x with plus 9x? Why you didn't do like a full equation?
The minus 2 is squared. The minus 2x squared.
Yeah. I got it, but if we put the both of them in the same line and we divide it by 3, so we'll have like the
Oh,
6
so
will
you
be
mean
3 and 2. The 6 will be 3 and 2, and we can take 3 from 9 and 2 from negative 2. Yes.
you mean this, right?
Yeah.
Yeah, it would basically be the same. The problem is, this is the same thing that you brought up yesterday. In order to cancel anything, you'd need to take a common factor out on top. And there is no common factor between 2 and 9. So this would actually be finished if you wanted to stop there, right?
Oh,
You would have to, yeah,
I got
there's no common factor on top. You can't do that.
Thank you.
No problem. All right, so I'd like you to try C and D, if you don't mind. They're not long. They're very quick questions, actually. I just want you to solve it. Make sure you know what you're doing. While you do that, I'm going to write out my solutions for A and B. So take 1 or 2 minutes and try to get C and D done. Y equals root 4x. It would be plus or minus root 4x. I'll give you a hint. If you see squareds, you should try to isolate the other variable. Or in other words, try to avoid square roots because they end up breaking it. I know I didn't mention that, but you want to avoid the square root. What I mean is try to avoid this 2, solve for the x instead. Okay, so I did the first 2. Again, that's just there for reference. I'll work on C now, and although your answer's not wrong, it's just that you're missing part of the solution, and I kind of didn't tell you to avoid the root because we don't know why we would avoid that yet. Turns out if you got that answer, you would break the function. It wouldn't actually be a function anymore. So anyway, I wanted you to see that for yourself. So I'm going to solve for the x. That means that I'll just rearrange this, put 4x on the other side. I just switch them so you can see it easier. Now x is clearly 1 over 4 y squared. And of course, you could write y squared over 4. It's the same thing. It's just personal preference. I like to keep the coefficients outside. Now we'll notice x depends on whatever you put in y. X is the output here. So it depends. X is the dependent. Y is the input, or the independent. You can put anything in for y. It's your choice. It doesn't depend on anything. Finally, let's see, in the part D, I've written here there's 2 possible answers. You can solve it for x or you can solve it for y, and they will both be equally simple. If you solved it for y, it would be 4x. I'll let you check that yourself. If you solved it for x, you would get 1 over 4y. They're both perfectly fine as answers. The y here would be the dependent because it's isolated, it's alone, it's the output. X is the independent because you can put whatever you want, it's the input. For the second one here, x is actually the dependent and y is the independent. Right, so that's why when I said there's 2 possible answers, that's what I meant. You can make the function in 2 different ways. So before I move on to a different type, are there any questions you have on any 4 of these questions or any of this topic so far?
Yes, if I solve question C for y, so the answer it will be like positive 2x and minus 2x, right?
You would get this. which is really plus or minus 2 root x. That's what you would get.
Okay, thank you.
And there's no way of you knowing right now that that's not something we're really allowed to do right now. So it's okay, no problem. So by the way, the answer that you gave in the chat, x equals y times 2/4, is perfectly fine. It's the same thing that I had here, but you didn't simplify. So make sure if you have 2/4, you of course divide both of them out and get your 1/2. Okie doke. So I'm going to move on to table of values. Table of values just to see how function. Actually, before I do that, I want to do something else. I just want to quickly graph this so you see what I'm talking about. So let's just graph. I'm going to graph this function right here on Desmos, okay? So we have, oops, let me move this. I want to have negative 2x squared plus 3x plus 1. So what we see here, this is that function. This is what it looks like. The independent variable is x. So for example, if I had x equals 0 for this, Hamza, can you turn off your mic? If you had x equals 0, if you put x equals into 0 for this, you would get back the number 1. So what it means is, and I can sort of annotate this, if I put in x equals 0, it would give you the number 1. If I put in x equals 1, it would give back whatever number this is, which it looks like a 2. So this must be the point 1, 2. If I put in the value x equals 1, y would give back a 2. That's why it's called dependent. I start with the x and I go looking for it in the function. That's our y, that's the dependent. Let's try another one. Let's say if I wanted whatever point this is. So x is something close to, let's say 1.8. That value should give me y equals 0. That's because I choose any x I want, and the output, the y, is what depends. So let me check that, and this will be the last thing I do for this. My question, of course, was over here. So y is negative 2. I'm going to replace all the x's with 1.8 and see what I get. 1.8, square it, plus 3, put in 1.8, plus 1. And I want to see what it gives me, because I want to see if this function actually gives me back what it looks like it's going to give me back. Now it should give me back 0. Let me see. Negative 2 multiplied by 1.8 squared plus 3 times 1.8 plus 1. It gives me negative 0.08. So it pretty much does give me 0. This is a little bit ahead of where I wanted to get with this. I just wanted to show you an idea of where we're going with this. Basically, what functions do, they take any x value. It's usually x. Any x value. It'll do something to that x value, manipulate it in some way, and spit out a new value. Which is why when we look at these functions, we can say, hey, if I give it a 0, it'll spit out 1. If I give it a 1, it'll spit out 2. It'll give me back 2. All right? Lots to think about. You don't need to understand all that yet. I just wanted to give you a big picture, okay? So I'll clear this out and go back to what I was doing here. Oops. What was that? Okie doke, no questions. So table of values. I already said that functions can be represented in 3 ways. First way is equations. We just did that. Second way is table of values, which you can see on this page what that means. And the third way will be graphing, which I actually just showed you. But let me show you this. First of all, it's saying a function can be seen from a table of values if there is a one-to-one relationship between the independent and dependent. Each independent value produces exactly one unique dependent. So what that means, that's just a lot of words to say each input needs to have a unique output. So let's just do it with an example. I'm going to redo this first example. The number 2. Take the number 2. What number do we get back if we put in -2? In this table right now.
1.
So I'm saying -2. What number does this give us?
Yeah, -8.
It gives us -8. Okay. Now let's move on. Let's see, are there any other -2s in this table? -2, -1, 0, -1, -2. Again, there is another -2, and it also gives us 16. That's a problem. The
No, it's
reason
only
that's a
2.
problem.
It's only 2.
Oh, 2, 2, 2,
Only-
2. I see it. Yeah, thank you. So it's okay. -1 gives us a -2, but -1 also gives us 10. Thanks for that catch. That's a problem. It's not a function now. The reason it's not a function is it needs to be 1-to-1. I'll write that down. Needs to be 1-to-1. What it means is one input gives one unique output. Let's try another one. Let's look at the second example here. We have, let's say, -2. What does -2 give us? It gives us the 3. -1 gives us a 4. 0 gives no repeats. There are no duplicates. There are no problems here. This is fine. This is a function. Okay, these should be very fast, okay? Just look at the table in practice 2A, this table here, and tell me, is it a function or not? Does it represent a function, yes or no? Remember, you're looking to see if there's any
Yes, it
duplicate
is.
ones. You're saying yes? I would agree with you. Do you have any explanation?
Yes, because every input there is a unique output. 8 gives us 14, 9 gives us 12, 10 gives us 10, 11 give us 8.
Yep. For every number you take, you just get one output. So that's exactly right. I even wrote down what you said because it was a perfect answer. So good job. Every input has a unique output. For B, we need to see if this is going to be a function. I have a feeling it's not just because of the way this is done. Let's see, -2 maps to 0. -2 also maps to 4. So right away, that's a bad thing. It's not 1-to-1. So we have to say it's not a function. You only need one example. Are there any other numbers that break the function? I can see here that it maps to 0 and also maps to 4. That's a problem. It looks like -1 is in 2 places. That's also a problem. So -1 we can see maps to 1. If we, for example, it's like, I'll explain it in a second. Okay, so 2 cases where it's not a function, okay? Just to get my explanation finished. What this means, the reason this is important, functions are just rules that numbers need to follow every single time, okay? If I put a 2 into the function, it should always give me back the same number for that 2, if it's the same function. So imagine it this way. You have a group of 5 people who go to the movies together, and you go up to the counter, and you're like, okay, there's 5 of us. We want to go see the Avengers or something. And they're like, okay, that's going to be 150 real. And you're like, okay, cool. Here you go, moving on. And then another group of 5 people comes, and they want to see the Avengers, and then they're told they have to pay 300 real. Well, that's obviously not okay. Or another 5 people come and they have to pay 1,000 real. Like, that's a problem. It has to be the same rule every time. So functions are just rules that you can always trust to give the same number every time, all right? If we can't trust it to give the same output every time, not a function. So that's the idea here. before I move on to the next section, there's not a whole lot left to do, honestly. But before I move on, is there any questions on that? If we do end early, I will do a little bit of review for the assignment, but I don't think it's going to happen. No one? Okay, I'll move on. So finally, of the three ways to make a function, remember there's equations, table of values, there's also graphs. I find the book makes it seem like these are three different ideas, but let me go back to Desmos for a second, just to explain to you that these are all the same thing. Look, this is of course our function, all right, over here. Let me go back and make it a clear function. Y equals, oops, y equals this. This is our function. The nice thing is that we can actually make this into a table of values. You know, this function has been made from this table of values if we want it to. For example, if we put in the number 2, it gives back the number negative, let's see the whole graph here. Negative 2 is negative 13. If I put in the number negative 1, it gives back negative 4. If I put in the number 0, it gives back 1. If I put in the number 0.75, it gives back 2.125. And finally, I put in the number 2, it gives back negative 1. So this is all three ways of looking at a function all in one place. There's an equation there, there's a table of values, and there is, of course, a graph. We can see it. So these are not separate ideas. They're all the same idea, just looking at it from different perspectives. All right? So let's go ahead and, with that in mind, move ahead. How do you know if something's a function? You do the vertical line test. What this means is you draw a vertical line. If that vertical line, no matter where you put it, always touches at only one point, then it's a function. So no matter where you put it, it only touches at one point, it's a function. We say it passes the vertical line test, VLT, all right? If it touches twice, or 3 times, or 4 times, at any point, it does not pass the test. It is not a function. So let's draw another line through this. I'll draw a blue line. Right away, the first point that I chose, the first line I chose, it's a vertical line. It touches at 2 points. It's not a function. It fails the vertical line test. So draw a line, hit once, pass. Draw a line, hit 2 times, or 3 times, 4 times, fail. Let me draw you a couple functions here. Is this a function? Yes, because no matter where I draw a line, it's only hitting once. Okay, it's a function. Is this a function? Well, no. What if it was like this? Well, that would only cross once, so it would be a function there, but it needs to pass it no matter where you put it. So this, of course, hits a bunch of times. It's not a function. What if I had something like this? You know, a sideways parabola. Right away. It doesn't pass the vertical line test. It's not a function. So this is the way we think about this. I want you to go ahead and just very quickly, you know, you can give me 4 answers, y, n, y, n. Try these questions. Just tell me yes or no, is it a function? Abdo's been very good today responding to all my questions, but I can see there's many, many of you in here today. Don't be afraid to type. I know some of you are probably like lying down in bed just like, oh God, make it stop. But it's never gonna stop. It's not gonna stop until the end of intercession. So you might as well engage, try to get your brain on. So you're saying A is a function. I'll draw a line through it. I'll give you some sample lines. Of course, you don't need to draw the same lines as me. C and B are functions. Let's just see. I'll write down what the kind of answers I'm getting here. I'm getting a no. I'm getting a yes. I'm getting A is not a function. Okay, another no. C and B are functions. So that's a yes and that's a yes. Let's see what else we got going on here. This is all I have so far. No one seems to be making up their mind for D. A is not, but the rest is yes. So I'm saying this seems like a function, but A is not a function. Okay. For those that are going to interact, I think I probably have reached my limit. Let's see what we actually have here. First of all, you can easily, take a pencil or take a ruler, whatever, and just, if this is your function, you'll scan the function. Literally, you can scan it across the page and just say, does it touch more than once? How I'd like to show this here, like I'll take my line, this is my ruler. Does it touch? Yes, it clearly touches twice. It's touching twice this whole time. That is not a good thing for functions. So this is not a function because it passes, it fails the vertical line test badly. The test is a 1 point, right? Let's check this. This function, no matter where I put it, it looks like it only touches once. No, 1, 1, 1, 1, 1, 1, 1, no matter where I put it. So 1 is good. This is a function. So whoever said yes for this one, you're correct. This one, by the same idea, it's a similar function. No matter where I put it, it only touches once. That's a good thing. That means it's a function. And then finally, D. I don't think I got a single answer for D except for Abdul, you said the rest is yes. Well, let's see. I'm going to take this line. This line's a little bit hard to see. Let's make it purple. Sometimes it looks like it's a function. For example, if I move it over here, it's yes. Yes, 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 yes. No, 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 no. Yes, yes, yes. So I'll show it like this. You need to pass the vertical line test no matter where the vertical line is. Okay, that's all my vertical line tests. The purple is the VLT. Pass, pass, fail, fail, pass, pass. If it fails at even a single point, not a function. So you've got to, of course, say that. You missed, yeah. Last one is no. So, clear? Use your pencil. This is your vertical line test. Vertical means up and down. I think that's the only hard thing to remember. And if it touches at 2 points, not a function. A little bit later, we're going to do the horizontal line test. So we just put it sideways. Same idea. Any questions on that? I feel like it's clear. Okay. We'll do the last topic, which is called function notation. Now, if you've seen the videos, then you'll know this isn't too difficult. Function notation is just the formal way, the nicest way to write a function so that it's perfectly clear. It's a way, essentially function notation, let me highlight what I need. Function of x is the same thing as saying f of x. It means function of x. It tells us what our function depends on. So if it's f of x, the function depends on x. If it's f of g, it means the function depends on the g, whatever that g number is. We just put numbers in, it depends on it. Let me show you what we're going to be doing. Essentially, we're going to be building functions here. And so I want to show you, I think this will work. Yeah. Anyone who's been in my physics classes knows that I like my simulations. It helps. So let's just say we wanted to make some equations here. So what do we want to do to a number? I can take any given number. Let's just say I want to multiply it by 3. So I'll take the number, I want the magic machine to multiply it by 3. And then do I want to add something or subtract? Someone give me a number, a positive or a negative number between 1 and 10. -9. All right. Negative. I think you missed the numbers out. So -9. So I'm going to, my magic function maker. Oh, sorry. It only goes to 3. Sorry. So I want to subtract 3. All right. What this function is going to do is it's going to multiply the number by 3 and subtract 3. So if I give it a 2, for example, I put the 2 in. Right now, it should be multiplied by 3. It should be a 6 now, even though I can't see it. Now it should be 6 minus 3, which is 3. So when it comes out of here, it should be a 3. Magic. Who said math can't be fun? What if I put a 1 in? And multiply by 1, take away 3, it comes out with a 0. What if I put a 0 in? 0 multiplied by 3 is still 0. Take away 3, it should be -3. Okay, let's open up these holes so we can see each step by step. What if I put a 6 in here? I put a 6 in, multiplied by 3, what does it do? It's 18. What's 18 minus 3? 15. So it should pop out a 15. Oops. 15. Okay. So again, I know I'm piecing this together very slowly for you, but it's important that you understand functions just take inputs and give outputs. You might still be asking, but how does this relate to all this stuff? You know, I've got things that look like this. How are you going to help me? Well, the function is just whatever you put in, so some number multiplied by 3, and then take away 3. So really, this is 3x minus 3. So this function machine should be the function 3x minus 3. And if I look in the background here, it actually is. It says it's 3x minus 3. Now, if I open up the other slots, this is the table of values for what I've put in here. This is all the possible table of values that this function could give me. And then what do you think's behind door number 3? What's behind door number 3? Anyone have any guesses? That's a 6. No, what I mean is the graph. Okay, so if this is the graph, what kind of function is this? Well, we can see that it's actually, if I was to continue this pattern, should be a linear function, should be a straight line. Okay, this is the idea. Again, some of you might already know about functions, but I wanted to make sure that you have a good idea of how functions work. So let's go bring this back. What the functions do is take any number and then do some magic on it, right? Do some manipulations. And we just use function notation to help us do that. So for example, these examples were done by Tom. I'll do these ones. Let's look at this question. It says, evaluate the given functions. That means get a numerical answer. It means just get a single answer out of this. Sorry, my pen stopped working there for a second. Get a numerical answer, which means get a number. So put the number 7 in for x. Every time you see x, make it 7. Okay? So what this means is the function, before we start, this is the function that takes any number, multiplies it by 3, takes away 5. So we say the function, when x is 7, is 3 times 7 minus 5. What's 3 times 7 minus 5? Well, it's 21 minus 5, or 16. And you'll notice that in the original function, anywhere where it used to be x, it's now 7. That's all function notation means. That's all there is to it. Function notation is just a nice way of showing how functions work, where the x is clearly there in the function, and all we need to do is replace it. It's more detailed than y equals f of x, okay? It is the same thing. They mean the same thing, but f of x lets us see what it depends on. See what the function depends on. So yeah, Khalid, so it's only about substitution? Yeah, pretty much. Function notation just tells us what the function depends on, and then we replace that, and it replaces it throughout the whole function. It's a way of substituting. So I'd like you to try B and C. We've got 9 minutes left, but the rest of this section is actually, almost the rest of the section is just practice. So I want to make sure you can do these. So take 1 minute. They shouldn't take any more than 1 minute to do B and C. I'll put the answers here so you can check. I'll do the full thing, but I want you to see what the answer should be. Okay, that's probably enough time. Hopefully not just Khalid tried this. I want most of you to try this. So again, it says, what is the function f of q? Remember, this is pronounced f of q. The function f, which depends on q, is given by this rule. And it wants you to evaluate it when q is -2. So you just replace all the q's. I don't need to erase that actually. Replace all the q's with -2. So f, when q is -2, is 3 plus -2 over 5. And I'm always very picky about this stuff. Try to use brackets because it makes sure that you never make sign errors. This is now 3 minus 2 over 5, or 1 over 5. Did anyone get C? If not, there's still time. Remember, we're going to take this 3, and every time we see the letter it's replacing, notice it's S, it replaces all S's with 3. So F, when S is 3, is 2, 3 squared plus 4, 3 minus 5. So once again, I'll just make it as clear as I can. I'm just replacing these S's. That's 18. This is 12 minus 5. And finally, this is 25. Excellent. So while you're working on this, I'm almost done. I just want to show you in Desmos once again that I'm not just making this stuff up. You know, this, oops. There's good math behind all of this. Let's put in the function. The function f of s equals, what's our function? 2s squared. Well, I'm going to have to go get s. 2s squared. You can put this on your phone. That's why I want to show you how I do it. S minus 5. So when this function is 3, I should get the number 25. Let's go looking for 3. 3 is over here. 3, 3, 3, 3, 3. Let's squish this down. Let's zoom in a little bit. Let's look. Can we find it? Can I find it? It should be 25. That's 3. Yep, it is. Now I'm having trouble getting it down exactly, but you can see that hopefully. We've confirmed the answer. And finally, if you want to use Desmos to check your work here, just type f of 3. Oops, sorry guys. F of 3, and it says equals 25. So notice I wrote the whole function out here, and then f of 3 gives us 25. That means when the value is 3, it pops out at 25. I'm explaining this in full detail because we use functions for the rest of the course, all right? They come up a lot. It's a good idea to know how they work. So that's a good recap on how they work in case you haven't seen much of them before. I don't know who's jumping in, out, in, out, in, out, but hopefully they're okay. The last section is the same idea. The only difference is it gives you a few different functions. You just choose one or the other. I'll do one very quickly for you, and then we'll be ready. You can go on and get ready to do your assignment. In B here, we need to take H when our value is 2, and we need to do F when our value is 4. So we take this, put 2 into it, take this, put 4 into it. Let me try and make it clear. Use this for this one, use this. So I'll replace this with 2. Plus. Okay, hopefully that's clear. And then when you solve that, I'll just give you the final answer because I want to give you as much time as I can. That's 12 plus -4, which is 8. And again, all of this is our H. All of this is our F. Okay. I'm rushing at the end here because I want to make sure I have time to give you for your assignment. So that's pretty much it. The reading values from a graph has been done by Tom. It's very, very simple. You just look, okay, when x is 2, what is it? Well, this is x equals 2. What value is it? It must be 3. So when it's 2, it's 3. But again, Tom explained that. Let me show you where you need to go right now to get your assignment. You should be on your D2L shell, okay? If you haven't logged in, you need to log in. This is the only place you can go get it. In your D2L shell, on mobile, it works the same way, but I recommend using a PC or a Mac. Go to your section, section 6. The quickest way you can do this, there should be a Dropbox or some notification in here. Let me look at it as a student. And let's see if there's any notifications. There's not. But the quickest way you can do this is you can go study for assignment 1. You can click this assignment 1. It will bring you to the Dropbox. So you click that, unavailable quick link. That's okay because it's not open yet. So just go to assessments, Dropbox, and just wait here. Hang out. Look, practice assignment is open. This opens May 3rd today, 10 a.m. That's in 1 minute. So you can keep refreshing this page. Just wait until it opens. And then once it opens, open it, download it, do it, get it back in half an hour, okay? Right back in the Dropbox. I only accept PDFs, and I only accept a single file. If you don't do either of those two things, you're not completing the assignment appropriately, okay? So now it's 10 o'clock. This assignment should open, so it is. And good luck. I'm actually going to keep this Zoom open in case you have questions, but go, do your thing. Come on, go, 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 go.